All right, let's get started here. Now, I want you to notice for taking the final on campus, I had these 2 times listed, but actually the one that would be much better for you to come to would be the one on Tuesday, June 12th, 10:30 a.m. in Science 108. And that's simply because there's a lot more room in there. In Taylor 20, that's my usual lecture face-to-face class. They're just kind of used to having themselves there. And if I had a whole bunch of strange people coming in on the final, it might seem a little strange to them. So I still offer it, but if you really couldn't come to the Tuesday one, it's the math block exam. So like if you had another math class, you probably couldn't do this and you'd have to do the Monday one. But just want to let you know about that. So here's what's going on this week. It looks like we're going to be covering lots of extra topics. Really, we're not. We're just going to cover the Bootstrap confidence interval. Oh, let's see here. Is this 243? I thought we had a lecture tonight. Oh, no, the Math 243 is tomorrow evening. This is Math 244, so you probably won't get this too much. Yeah, so sorry about the confusion. Usually I've been having the 244 on Tuesdays and the 243 on Wednesdays. Everything got shifted over this week because of the holiday. Okay. Let's see here. Yeah, so 243 will be tomorrow at this time. So I'll see you there. Okay, so sorry for the confusion. And so those of you who are here for 244, stay in touch. Okay. Now let's see here. Let's go ahead and get into this. Now, so like I was starting to say, we're just really covering one other topic. It's Bootstrap confidence intervals. And of course, your task is, it's not very much reading to do, but it's a rather fascinating topic because it's ingeniously simple. It's, as you're going to see, it's really easy to do. And the nice thing is, it is a non-parametric method. You don't have all those conditions that have to be met. And it's relatively new. It came up with in the late 70s. So for the binder assignment, do you want the snapshots? Yeah, I'd like to have those before the final. So the idea is that you'd have it done by Friday of next week, which is technically the last lecture class, for regular face-to-face classes. And the idea, and so that's why I want to mention that we're just doing one topic. So that's going to free up a lot of time for you to really focus on reviewing all the methods that you've covered. And a great way to review is to work on that little stats binder or stats toolbox. I keep calling it interchangeably between the two. Because boy, does it make it easier for you to remember all the different methods if you've got the perfect ideal application that's something that you find interesting, hopefully even fascinating. So you've got, after you see what we're going to do for today's homework, you go, well, that won't take very long. And so giving you this week and next week to really do a good job on the stats binder. And so if there are any who had missed earlier, you can still go back and, so you get all the different topics done. All right, so let's go ahead. Let's move that out of there. And, let's see. Let me take a look at my calendar here. Trying to see what I said here in this checklist. I said here June 3rd, and I want to adjust that here. Hold on. So June 3rd. So no, it won't be June 3rd. I'm going to give you until June 8th. So I should change that in my little checklist. So if you get to me by June 8th, that's fine. So that way you've got this week, the second half of this week, and you got next week to, really put some time in on that, because it's really going to help you do better on the final. So I'm going to make a note to myself, change that to June 8th so everybody knows. Now, let's see. I had a question up here. And let's see. I'm a little confused. Is the stat binder doing third? Okay, so I just answered that for you after you had already typed it. Yeah. So yes, that did need being cleared up, because there's really no need to get it in that soon. It'd be better if you were using that time this week and next week, to get a really good job on it. Okay, so let's get that. See, we don't need this here anymore. So what we're going to do is let's get the little lecture notes. Oh, let's see here. Got a question. For the take-home portion of the final, how long do we have to complete that part? So I'd like to have that by Thursday of finals week, because I always make that the last day for the final. So I'll make a note to make that clear too when I give the instructions. Thursday finals week for the take-home part. Okay. Now, so I guess we should sort of explain, this is a pretty wild concept if you haven't read it yet. I remember first time I heard it, kind of blew my mind a little. But you take one random sample, and you're going to just take samples from your random sample. But the only thing that makes it work is it's selections with replacement. So imagine you select one from your random sample, you basically write it down, put it back, and then you take another sample from there, write down what you got, and put it back. So you're just sampling from your sample. And you might wonder, what does that accomplish? Well, you're sampling from your sample, but it's with replacement, and a rather amazing thing happens, is that you're creating a sampling distribution because each of these samples that were taken from your sample of some size n, probably the same size n of your actual sample, you're getting a sample mean from each of those. And you keep repeating the process until you start developing a sampling distribution. But the wild thing is, what's in the center of that sampling distribution is the sample mean. In fact, let's get over here to the textbook where it was talking about this. Let's go back over here. But you see this, so essentially all those sample means that you're getting from repeated sampling, and you're getting your sample from one random sample, but they're clustered around just like a sampling distribution. But the sampling distribution you first learned about, that theoretical concept, that all those sample means would cluster around the population mean. Not this one. These are going to be clustered around the sample mean. The sample mean will be in the center. You may think, oh no, that's not going to work, is it? No, it works perfectly, because you've already got the sample mean in the center, and now it's been a long time since you constructed one of these things. But the idea is, in fact, here, let me hook up my little writing tablet so I can just sketch this out a little bit. And I got my little annotation tool up here. And let's first put in a straight line. So I'm just going to do a little straight line here. Whoops, I didn't mean to do that. Let me erase that. I'm going to try that again. Well, we got a straight line here. So that's our little axis here. And when you constructed your confidence interval, in the center there, that would be where your sample mean was, right there in the center. And then, if you remember, once again, I know it's been a long time, you calculated this equal distance above and below. and that was called your margin of error, E. And you had to calculate that. You had to find how many standard errors you needed to go above and below. That's some z-score, multiplied by the size of the standard error. And the standard error was given by this. And so you had to do that calculating, got this value and subtracted it from the sample mean, got the lower bound, added, got the upper bound. But what we're doing here is so easy because look, the sample mean is already in the center and you've already got the middle 90% here. All you have to do is find this value and this value. And the thing is that this in the center here is 95%. Well, you know, the two tails add up to 5%, 0.5% here. So this is the 2.5th percentile. See if I get this to right. Well, it's being difficult. And over here, see 95% plus 2.5, this is the 97.5th percentile. Well, the computer can just get that for you. It just find out, okay, the 2.5% of all the sample means are here. Find the sample mean that's right here where 2.5% are below and 97.5% above. And over here, find that sample mean where 97.5% are below. And the computer program will do that quick and easy. And so that's all there is to it, just by sampling from a random sample, but with replacement. But go ahead, it's just 3 pages, but read it through to wrap your head around it. It truly is ingeniously simple. And, you know, you're pretty lucky because StatCrunch really makes this easier. You have it so much easier than my lecture class that has to use Minitab Minitab doesn't have it streamlined like StatCrunch does. So let's go ahead. Let me get rid of my little scribblings here. I don't know whether this helped or not, but if you read the textbook, it explains it quite well. And you may not have had a chance to read it yet. Okay. But so here's what you're going to be doing. So you've got the homework here. And of course, you're getting this from the textbook through my stat lab. And, you know, anyone that looks particularly interesting to you. So, for example, I'll just do this one. So what I got to do is, so I'll go ahead and pull this out. So that way I'll be able to see the data. And I'm going to put that into StatCrunch. So we'll just go over here and let's go to the main menu. Let's fire up StatCrunch. So, you know, it's not too big a data set, so I'm just going to enter it in. It's not going to be any big deal, but I'm going to go to the StatCrunch website. And let's just do this. Type or paste data into a blank data table. This one will do just fine. Now, if you want, you can give it a name. Let's see, so represents the prices. So I'll just call this prices. And then I'll just go ahead and type in the data. It's a pretty small data set. Now, in actual practice, you would like to have a bigger data set, but this is enough to give you an idea. And of course, as a bigger data set, I would make sure I had it in an Excel spreadsheet so you could quickly, easily copy it in. So 13.76, 1595, and 1475, 1788, 1499, and 20.49. Now I better double check myself here. Make sure I don't have a data entry error. All right, so we got that in there. Now here's what you do. you're going to just follow these screenshot instructions you have from your learning module. There's not very many steps, thanks to StatCrunch. So just do what it says here. We're going to click on Stat, go down here to Resample and Statistic. Now, so what we're going to do is select our data here. Now, the only thing that might seem strange is right here, and what you do is you're going to type in mean, because we're doing a confidence interval for the mean, and then in parentheses, the name of whatever you gave the column. So it'll be prices. So whatever name you put in there, because you can see here, I just had data, so that's why I put data right there. So whatever the name is. Now, let's see what other settings do they say. So select the Bootstrap rate button. Good, because that's with replacement. That's what makes it a Bootstrap method. And then select the univariate. Okay, so we want to resample columns at different rows. And in the box for number of samples, enter 1,000. So that's how many times it's going to repeat this process. It'll repeat the sampling process 1,000 times. And that'll be enough to give you a good approximation. You could do more, but I haven't played with it. Maybe I think it'll let you do more. Now, so here, they've already got these in here, but all we want is the 2.5th percentile and the 97.5th. I mean, you could have the others too, but this is the only two you need, because that'll give you the lower bound and upper bound for your confidence interval. Now, if you'd like to, this is optional, as it says, to store resampled statistics in the data table. And that's it. This is all you got to do after you get the data in. Let's click on Compute and see what happens. All right, now let's resize this. So we are 95% confident that the population mean is between 14.104 and 16.931. In fact, here, let's go to over here. You can see an example of doing this interpretation, just like we have all along with this. Of course, you can also put it in context of population mean of and give the context if you wish, but you're just giving you the lower bound and upper bound. It feels similar to when you were using your TI calculator and then later on StatCrunch every time you did a confidence interval. You're just given the lower bound, upper bound, but this is being done with a resampling method. And you don't have all those conditions that need to be met. Oh, and look at this. If I click over on this little right arrow, there's a picture of all those sample means from the resampling process done 1,000 times. So it's nice to have a little picture there. Oh, it's got another picture here showing the QQ, or also known as the probability plot. Yeah, it's looking pretty normal there, but you can see that here too. Approximately normal. And that's it. That is all there is to it. So compared to some of the other things you've done, like two-way ANOVA, that were so involved, this hopefully seems super, super simple, but it's very useful. It's very going to be very popular because it's not so demanding, and it gets the job done. And so, I for an extra topic, this was an important one, and it ties in very well with the non-parametric methods you've been learning. All right. And so the idea is that in the homework, there's a number of them there. You can just pick 3 that look interesting to you. And after that's done, just focus your time on, reviewing the past concepts. Oh, now here's something I'm working on. Let me show you what I've got so far. Let me get over here. See, 244 online. Solutions. And let's see, one that's for you would be like this one. Okay, so this is something I'm going to have for you in a couple days. And it's to give you a good idea. In other words, I'm going to be, providing these solutions so you can really see kind of what I'm looking for on the non-parametric homework. So for example, so this is the one sample sign test. Now this is how I'd like you to do it, because this is how I would like you to approach all these situations where there's a first choice, second choice method. So I'll start being ambiguous. I'll say center. You say, I wonder what center is, mean or median. Well, if it meets the requirements of your first choice, it's going to be the mean. If it doesn't, you'll be your second choice and it'll be the median. So once again, I will have this available to you, but hey, you get to see it now. So I'm saying, okay, let's see if the conditions are met for the first choice. Random sample, you go, hey, it didn't say so. So you should mention that that concerns you, because hey, if it's not a random sample, there's no statistical method to make up for that. But then you say, well, now, if it was a random sample, it would be all right. The other thing is we have a sample size less than 30, and I don't know if this thing is normal. So what we're doing in this class is using the Shapiro-Wilk normality test. And so these are basically your two hypotheses. And when you run it, you'll get a p-value of 13.35%. So you're going to stick with the no. I guess we don't have a skew. Well, then that means we get our first choice. So on this one, even though it was non-parametric, this first one, the first choice conditions are met, so you're going to use the first choice. And so that's what I'm doing here. That's why we're using the population mean, because it met the conditions. And then, of course, I'm following up with a confidence interval, as you can see here. And then after all this work, I post the outputs. In other words, this just supports my work up here. So you can see that. Notice that when the conditions are met, because you were doing this Shapiro-Wilk, they say, hey, they're met. Hey, everything I need is right up here, because now you've already got the p-value to this hypothesis test. Okay. But if this was a small p-value telling you there was skewed, then you'd have to go and run the second choice method. So let's look at number 2, where that happens. So with this one, as before, you'll find similar method here. I'm checking all of this. This time, at least they said the sample was random. And I'm doing this, but this time I got a p-value of 1.62%. So I reject the no, accept the alternative. Population's not normal. I don't get to use my first choice. I'm going to have to do a second choice, the one sample sign test. And so, and of course, when I'm doing this, I'm making super clear, I'm talking about the population median. I mean, if you just said median, that's all right. But I'm just being super clear in my work here. And of course, when I did stat crunch with one sample sign, then sure enough, I was able to reach my conclusion, which was fail to reject the null. And then I'm stating it in context. But notice this, even though it didn't ask me to, I followed up with a confidence interval because I got a burning desire to know. And it's so easy to follow up because, as you recall, whenever you do this, you can go up there in the upper left-hand corner, click on edit, and just select confidence interval instead of hypothesis test. And so here's the output. So when I ran it the second time, I got the confidence interval, put that in there. And this was the work from the hypothesis test for this one sample sign test. So I want to have these created for you so you have a good idea of what I'm looking for, so that therefore when you're working on your take-home final, you'll know how to really show off. Okay? So once again, we got this up here. Look, I got nothing else to cover this evening. So I'll go over this. And if you've got any questions, you ask them now, because we're going to be done here pretty soon. Because this Bootstrap confidence interval is too darn fast and easy. So once again, I'm checking conditions. Once again, I got a small p-value telling me that the population isn't normal, so I'm going to have to use my second choice. I also threw in the box plot and the QQ plot, but you know what sometimes happens? So don't be surprised if this happens, where say the p-value's big, telling you, look, you don't have a problem, and yet when you look at this, you might have an outlier. But you'll find that's usually not a very extreme outlier. So if you had to choose between the two, I would go with a Shapiro normality test and go with what it says. Let it make the deciding factor on whether the conditions of normality are met or not. All right, so here you are using your second choice. And of course, you know, when you're doing this, you're just looking at the lecture notes, reminding you of the steps. I don't expect you to remember the steps on using StatCrunch. It's fine to use the lecture notes for that. Because because I'm, you know, I switch between using this and Minitab, and sometimes I forget. Now let's see, which way is it for Minitab versus StatCrunch? So, you know, even I need to resort to those screenshot instructions, especially if it's been a while since I've used it. So, you know, so you might remember to download and save those lecture notes so that when a situation comes up and you need to be using this stuff, you've got the screenshot instructions to remind you how to use StatCrunch. And the nice thing about StatCrunch is it's so inexpensive. You've got it free now, but maybe down the road you want, but don't worry, it's not an expensive one, which is nice. Way back in the early days, it used to be free. But now they charge a little. Oh, let's see, question. Okay, so is the in-class final going to be questions about conditions and methods? Yes, it's going to be like exam 2. A little more emphasis on what's the first choice method and what's the second choice method. Now, of course, you notice not everything has a second choice method. You've probably noticed this. The statistical methods for categorical data, they don't have second choices. It's the quantitative data statistical methods that have the second choices. So that's the sort of thing you can expect. Similar to that, but with the added twist of what's the first choice, what's the second choice, and the conditions. So you really got to know your conditions in order to know whether to be using the first choice or second choice. You know, I might give you enough information in there that you would be able to know whether you got to use the first choice or second choice. All right. Oh, I want to make sure I was looking over this. It does not say anything about a take-home final. Well, probably didn't say anything about the second midterm being take-home. So it's just that because you need a computer to do this, you can't have a computer in there with the final. So that's why we break it up into 2 parts, that you got the in-class part and the take-home part. And it's something we didn't have to do in Math 243 because we were able to get by with the calculators. But you're so far advanced, you've far outgrown that calculator. So you've got to be using computers now. And so that's why it works out well doing it that way. And think of it this way. The in-class is really testing to see what you got up in your brain. The take-home portion, it's an example of, okay, let's suppose you've got a report to do in another class that requires you to use statistics. And you're just showing what a great job you can do. Sure, you have to refer to the lecture notes to remember the steps and all, but by golly, you're doing a professional looking job with everything, pasted in there. And if I have some examples like this here for you, you got a good idea of what I'm looking for. So you don't feel like, because you may have felt like you were really second guessing what to do on this homework. So what I'm going to do is the same thing I did with my lecture class today. I finished making their answer keys. Now I'm getting started on yours. I'm going to have these posted. I'm going to ask you, to compare these with what you did and see if there's anything lacking in your work. Just to give you an idea that, okay, so when I do this on the take-home final, I'm going to make it look more like this. So that's the purpose of that. Let's see, with number 4 here, let's see what happened. Hey, with number 4, with this one, the Shapiro-Wilks test had a big p-value. You got, just like the first one, in number 4, you got to use your first choice. And so you had 4 problems here. 2 of them, you got to use your first choice, and the other 2, you had to use the second choice. So you never know what's coming next, whether it'll be a first choice or a second choice. And also notice how I just show the StatCrunch output at the end as a backup support. But I'm showing all my work, my hypothesis test here. In other words, I'm not just using this in place of showing my work up here. In other words, don't just be pasting the output and think, okay, there you go. I gave you my hypothesis test. No, yeah, that's all the more reason why I need to be showing this, how you should be doing it. Okay. Any other questions you can think of? So you've been doing pretty good here with lots of good questions you've been asking. Oh, hey, let's take a look at the calendar here while we're here. Do I have it? Okay, so our next meeting, so we'll be back to Tuesday again. So it'll be Tuesday of next week. Have been reviewing. And so what we'll be doing, we'll just be working on practicing, recognizing which statistical method to use. And of course, hopefully you will have been working on that and getting better and better at it. And if you've got any questions, you can certainly show up to that and start asking away. Well, we've only been at this for a half hour, but we really did get it all covered. So tomorrow I'll be working on getting the rest. I got this one done, but I'll be working on getting the others. I can't just reuse the one from my lecture class because it uses Minitab and the output looks so different. So I need to go through and be sure and get all the StatCrunch output. But don't worry, I'm good at this, so it's no big deal. All right. Well, let's double check that if there aren't any other questions, we'll just have to say adios until next Tuesday. Okay? All righty. We'll see you next week.